Question number one. At Monday practice, Lonnie sprints 200-meter a total of 24 times. At Tuesday's practice, he sprints 240-meter a total of 20 times. On both days, he rests for 30 seconds between each consecutive pair of sprints. So Lonnie sprints at a constant speed of 8 meter per second. So question number one. On Monday, how many times does Lonnie take 30-second rest between the consecutive pair of sprints? Since he sprints for 24 times, so there will be a rest of 23 times. There will be 23 consecutive rest. So there will be a rest of 23 times. On Monday, question number two, Lonnie's total practice time. So on Monday, first we have to find the time for the one sprint. His speed is 8 meter per second. So the time for one sprint would be 200 over 8, and that is 25 seconds. So his total time for Monday would be the time for the sprint, which is 25 for one. So for 24 sprints, so we multiply, plus there is a rest of 30 second 23 times. So 30 or 20, 30 times 23. So it's going to be, that's going to be 1290. And then on question number C, determine how many fewer seconds Tuesday's practice will be as compared to the Monday's practice. So on Tuesday, the time for one sprint, which is of 240 meters, so we divide it by 8 to get the time. 8 is the speed, that's 30 seconds for one sprint. And since he has taken sprint 20 times, so the total time would be, so 30 seconds for one sprint, and there are 20 sprints, so 30 times 20 plus there will be a rest of 19 times in 20 sprints, so 19, and each is of 30, so we multiply by 30. So this is 600 plus 570, which is going to be 1170. So the question is, what is the difference between the practice time on Monday and Tuesday? So the difference would be 1290 minus 1170, which is 122nd. Okay, in the second question, consider the following arrangements of the positive integers, which is 1, 4, 1, 2, 4. So the first row has 1, the second 2, 4, the third row has 5, 7, 9, and the fourth row it's 10, 12, 14, and 16. So you can see in the first row there is only one number, in the second row there are two, in the third row there is three, in the fourth row there are four numbers, and if the row starts with the odd number, it has only odd numbers in the row. If the row starts from even number, like the fourth row starts from 10, so it will have all the next consecutive even numbers, 10, 12, 14, and 16. And all these are consecutive, like 1, 2, then 4. Okay. What, and also you should look at the last number of the row, which is 1, 4, 9, and 16. All these numbers are perfect square, and like 4 is the square of 2, which is the last number of the second row. 9 is the square of 3, which is the third last number of the third row. 16 is the square of 4, and which is the fourth last number of the fourth row, right? So the question number 1 is, what is the average of the integer in the fifth row? So the fifth row starts from 17, so it will have all the odd numbers, 17, 19, 21, 23, and 25. So the average of all these numbers will be, so divide them by 5, which is 105 over 5, which is 21. So 21 is the average. Question number 2. Which row has the integer 145 in its first position? So we consider that the nth row has the 145 as the first position. So the last number of n minus 1th row, so last number of would be 144. And we know that the last number is always a perfect square. So we can say that square of n minus 1 is 144, which is 12. So n is 13. So 145 is the first number of the 13th row. Look at the question number C. So determine the row and the position in which the integer 1598 appears. So 1598 is greater than the square of 40, and it is less than the square of 39. So let's consider the square of 40, which is 1600, and 1600 is the last number of the 40th row, right? So, and we can say it's the 14th, so 1600 is the 40th number of 40th row. So before 600, 1600, there will be 1598. So it is the 39th number of 40th row. It is the 39th number of 40th row. Question number D. The average of the integer of row R, 241. Determine the value of R. So 241 is greater than 225, which is square of 15, and it's less than 256. It means it is between the square of 16 and 15. So it means this is in row of, like, so we can say that 225 is the last number of 15th row. So first number of 16th row will be 226, and the last number of 16th row would be 256. If you find the average of these two numbers, 226 plus 256 over 2, that's 241. So it means R is equal to 200, sorry, R is equal to 16. So 241 lies in the row number 16. Okay, you must be knowing the divisibility test by 3 and 4. So if sum of all the digits of the number is a multiple of 3, then the number is divisible by 3. And if the number formed by last two digit of the number is a multiple of 4, then the number is divisible by 4. Question number 1, which is a 5 digit integer, which is 4b5b2, is divisible by 3. What are the possible values of non-zero digit b? So we add all the numbers and we get 2b plus 11. So now we substitute b with the different digits and we see whether we get a multiple of 3 or not. So if b is 1, this is 13. If b is 2, that's 18. That's 2, that's 15. If B is 3, it's 17. If B is 4, this is 19. If B is 5, this is 21. If this is 6, this is 23. If this is 7, this is 25. If this is 8, this is 27. And if B is 9, this is 29, right? So you can see that when B is 2, 5, and 8, we get a multiple of 3. So therefore the possible values of B are, so B is 2 or B is 5 or B can be equal to 8. All right. Now question number 2, the 5 digit positive integer we have here, which is ABABA, is divisible by 4 but not divisible by 3. It's divisible by 4 but not divisible by 3. So let's talk about divisibility by 3. So what we do, we add all the digits first. So we get 3a plus 2b. Now it has now two parts, 3a and 2b. So this part is already divisible by 3, and this part can be divisible by 3 if, so 3a plus 2b will be divisible by 3 if if b is either 3, 6 or 9. So this will be divisible by 3 if b is 3, 6, and therefore, because in the question is given that it is not divisible by 3, we have possible values of b. Therefore the possible values of b are 1, 2, 4, 5, 7, and 8. It means except 3, 6, 9, all the digits. Now we know that ABA is divisible by 4, and according to the divisibility test of 4, BA, if it is divisible, then BA should be a multiple of 4. Okay. Now, because B has, so we make the possibilities. What are the possibilities? So B has these number possible. So if B is 1, so either A can be 2 or it can be 6. So the pair can be 1, 2 or 1, 6. If B is 2, then it can be either 4 or 8. So pair will be 2, 4 or 2, 8. If B is 4, then it can be either 4 or 8. So it can be 4, 4, 4, 8. If B is 5, A can be 2 or 6. So it's 5, 2 or 5, 6. If this is 7, then A can be 2 because 72 is divisible by 4, and 6. So 7, 2 or 7, 6. And then you see B can be 8. So either A will be 4 or 8. So 8, 4 or 8, 8. So you can see there are 12 possible, There are 12 possible pairs are there. So different pairs of non-zero digits. So there are 12 possible pair of non-zero digits of A and B. Right. So this is the answer for the second one. Question number 3. A positive integer t is divisible by 15 but not divisible by 12. Determine the different number of triplets of non-zero digits A, B, C that are possible. So t is equal to, that is ACA2 times BAC. See, this is divisible by, if you look at the question, it's divisible by 15 but not divisible by 12. So if it is divisible by 15, it means it is divisible by 3 and 5, because 15 is 3 times 5. So it's divisible by 3 and 5. And if it is divisible by, not divisible by 12, it means 12 is what? That's 3 times 4. It means not divisible by, it means this is not divisible by 4. So it is divisible by 3 and 5, but that is not divisible by 4. We know that the divisibility rule of 5 is the unit digit should be either 0 or 5. So t has two parts, one and the second. So the first part has 2 in the unit digit, so it is not divisible by 5. Then we must be sure that BAC should be divisible by 5. So it is a non-zero digit, therefore C should be 5 because it's divisible by 5. So T is A5 A2 times BA5, right? Okay. Now it is not divisible by 4. Or we talk about the 3 first, right? Now we first see it is divisible, it is not divisible by 4. See, it's BA5 is already an odd number, so it is not divisible by 4. So either this is divisible by 4 or not. So it is not divisible by 4 for the values of A, when A is 1, 3, 5, 7 and 9. Otherwise, like if you take 2 instead of, okay, so it is divisible by 4. So it is divisible by 4 if you take A is equal to 1, 3, 5, 7 and 9. Okay, so it is divisible by 4. So because it's given that it is not divisible by 4, therefore the possible values of A are 2, 4, 6 and 8. So these are possible values. Otherwise it will be divisible by 4. Now we come to the divisibility by 3. Okay. So if t is divisible by 3, so either this is divisible by 3, the first part, or at least one of these two part is divisible by 3, or both are divisible by 3. All right. So what we do, we add all the digits of these parts, like A plus 5 plus A plus 2, that is 2A plus 7, and B plus A plus 5. So these are two parts. So because there are four possible values of a, we consider each value one by one. So if a is equal to 2, in that case 2a plus 7 will be 11. Okay. And b plus a plus 5 would be b plus 2 plus 5, which is b plus 7. So if, because at least one has to be multiple of 3, so possible values of b are 2, 5, 8, right? So these are three possible values. It means there are three triplets of a, b, c are possible. So three triplets of a, b, c are possible in this case. If let's say you consider a is equal to, what is the second possible value, 4, then 2a plus 7 has to be 15. And because now the first part is divisible by 3, then can be any b can be any positive integer. B can be any positive number from 1 to 9. So therefore we can say there are 9 triplets, 9 triplets possible of A, B, and C in the second case. So if B is 6, so what happened? If B is 6, A is 6, sorry. So A plus 7 would be 19. So B plus 6 plus 5, which is B plus 11, because one has to be, at least one has to be divisible by 3. So the possible values of B are 4. It can be 1, yes, 1, 4, and 7. So three triplets possible here also, three triplets possible. And if A is equal to 8, in that case 2A plus 7 is 23, and B plus 8 plus 5 is what? B plus 13. So there are possible values of B 2, 5, and 8. So here also three triplets possible. So how many? So we consider all these four conditions: when A is 2, when A is 4, when A is 6, and when A is 8. So how many triplets? So you see here each time, so three triplets in the first condition, 9 in the second, in the third condition three triplets, in the fourth condition three triplets. So 3 plus 9 plus 3 plus 3, so that's 18 triplets possible. 18 triplets are possible, okay, of AB. So in question number 4, in a lab there are 50 computers from 1 to 50, and if both and each computer is connected to the other computer by a cord, if both computers are numbered even, let's say one computer number 2 is connected to computer number 6, then they will be connected through a red cord. Or if both are odd, let's say computer number 7 is connected to computer number 11, because both are odd, so they will be connected through a red cord. So we can say if they are of same parity, then they will be connected through a red cord. Or if one is even and one is odd, let's say computer number 8 is connected to computer number 15. So we can see one is even, the other is odd, then they will be connected through the blue cord. Okay. Um, a route is a sequence of cords along which data can travel to get from one computer to the another. Okay, so data could travel from computer 5 to computer 12 directly. Let's focus on the question number 1. There is a route connecting computer 1 to computer n using only red cords. Since 1 is an odd number, and to get connected through the red cord, they should be of same parity. So we can connect by red cords only if the other numbers are also odd, because we've taken 1, so from 2 to 50 there are 24 odd numbers. So therefore the possible values of n are 24. 24 is the answer. Question number B. Show that for every pair of distinct computers, computer A and computer B, there is always a route between them that uses only blue cords. So between computer A and B, there is a route which uses only blue cord. See, A and B computer, we take A and B computer. So two things we can consider: either both are even or both are odd. It means either they are of same parity. It means either both are even or both are odd, or they are of different parity. It means one is even and the other is odd. So we'll consider the first situation when A and B are of same parity. Okay. So if A and B are of same parity, so if they are connected to each other, they will be connected through a red cord. But if we consider another computer which has the different parity, let's say A and B both are even, but we take another computer which is numbered C and which is odd. So now A and B will be connected through the blue cord, A and C will be connected through blue cord, and C and B will also be connected through the blue cord. Okay. So if they are of same parity, we can see a route that uses only blue cords. If they are of different parity, it means one is even and the other one is odd. Let's say A and B, one is even and the other one is odd, then they will be definitely connected through a blue cord. And this case also we can say that there is a route that uses only blue cord. Okay, so in both the situation we can find a route which uses only blue cord. So in question number C, it's given that red and blue cords are randomly replaced by green and yellow cords. They are replaced by green and yellow cords, and um, between 1 and 50 there is no route that uses only green cord. Between 1 and 50 there is no route that uses only green cord. We have to show that there is always a route between 13 and 14 that uses only yellow cord. Okay, so that we have to show. Now, between 1 and 50, there is no route that uses only green cord as per the question. So, the cord which is connecting directly 1 to 50 must be yellow, isn't it? That must be yellow in all the cases. So, cord between 1 and 50 must be yellow in any case, right? Now, if between 1 and 50 there is no route that uses only green cord, so there should be yellow cord in between. So there can be four conditions. Condition number one, the cord connecting from 1 to 13 is yellow, or cord connecting from 13 to 50 is yellow. 13 to Condition number two, 13 to 50 is yellow. Or we can say cord connecting from 1 to 14 is yellow, or 14 to 15 is yellow. 14 to 50 is yellow. Okay, so case number one. In case number one, we assume that condition number one and condition number three is true. Condition number one and three is true. In that case, one cord connecting between 1 and 13 is yellow, and condition number 3 says that 1 and 14 is yellow. So 1 and 14 is yellow. In that case, you can see there is a root between 13 and 14 which uses only yellow cord. So we can see that from so we can see from 13 to 1, and from 1 to 14 uses only yellow cord which connects 13 and 14. All right, case number 2. In case number 2, we assume that condition number 1 and 4 is true. 1 and 4 is true. 1 says that it connects from there is a cord between 1 and 13 which is yellow, and 4 says that between 40 to 50 is yellow. In this case also, between 13 and 14, you can see from 13 to 1, 1 to 50, and 50 to 14, and 50 to 14 uses only yellow cord. Okay. Condition number 3, or we can say case number 3, that says 2 and 3 are true. If 2 and 3 are true, so 2 says that there is a cord between 13 and 50 which there is a cord between 13 and 50 which is yellow, and third says that between 13 to 50 is yellow. So 2 says that 30 to 50 is yellow and 14 to 50 is yellow. Okay. So in this case, you can see that cord connecting from 13 to 50, and then 50 to 14 is yellow. So there is a root between 13 and 14 in this case also, where all the cords are yellow. Now case number 4. The case number 4 says that 2 and 4 is true. In that case, cord connecting between 13 and 50 is yellow, and then 14 to, okay, in case number 3, 1 to 14 is yellow. Okay, sorry. So in case number 3, 1 to 14 is yellow. In that case, from 14 to 1, in that case from 13 to 50, then 50 to 1, and then you can say from 1 to 14 is yellow. It means we can see there is a root which connects with 13 and 14 which is yellow. If case number 2 and 4 is true, 2 says it 13 connects 50 which is yellow, and between 14 and 15 is also yellow. So we can see in this case also 13 to 50 and then 50 to 14. So there is a root which uses only yellow cord. So every case we can see that there will always be a route which connects 13 and 14 that uses only yellow code.